What is CIRS? Um, so as the name suggests, chronic inflammatory response syndrome. Okay, so let's break that down. Chronic inflammatory, that's chronic inflammation. What does that mean? It's an ongoing inflammatory response in your body that lasts for at minimum a few months. Usually it's like 6 months. That's the diagnostic criteria for something to be deemed chronic. In reality, in practice, this is an inflammatory response that will be there for years, decades, for some people, their whole lives, and they don't know it. It's kind of in the back burner, sort of operating. So it's an inflammatory response. What's driving that inflammatory response? It's your immune system. The immune system is driving this hyper reactive inflammatory response. And what is the immune system reacting to? It's reacting to a very specific environmental stimuli. These are microorganisms, biological organisms that produce certain kinds of toxins or particulates. We call these particulates biotoxins. They're tiny, invisible particulates that could be in the thousands or hundreds of thousands that certain microorganisms will release as part of their behavioral response. And these could be fungi or mold. These could be bacteria. And there's a whole list of bacteria that fall in this category. These could be algae, certain algae blooms from lakes or oceans. Planktons, dinoflagellates fall in that category. Spider bites, recluse spider bites can do this. Um, and now we have a suspicion, and I'll say also tick-borne infections can do this. Lyme's, Bartonella, Babesia, all of these things can release certain kinds of compounds, biotoxins, that when the immune system is exposed to them, initiates this inflammatory cascade that's abnormal, it's hyperreactive. Now, the question that you can ask is, but why is not everybody showing this pattern, right? Why is it that some people seem to get sick and other people don't seem to have anything to do with this? Well, to the best of our knowledge, we now have data to indicate that there is a strong genetic component to this abnormal immune response. And it's part of what we call the HLA class 2 groups of genes. These are genes that are basically encoding the instructions for your immune system on how to operate when it encounters a foreign invader, an infection, or an antigen. So for roughly 75 to 80% of the population, the instruction manual is complete. So when the immune system for those people encounters a foreign invader, an infection or a toxin or an allergen, it goes through the normal process that we are typically used to perhaps experiencing and maybe hearing about, which is that initially you generate an inflammatory response from a part of the immune system that's called the innate immune system, which is the immune system, the part of the immune system that comes with you by design. It's a very rudimentary part of the immune system, and its job is just to send a battalion of armies of immune cells to start firing bullets across the board to try to kill the invader as soon as possible. This is when you get really sick, when you get a cold or a flu and you start feeling achy, feverish, when you start feeling congestion, sore throat, that's your innate immune response. It's very generic, it's non-specific. It actually impacts our own tissues, right? So when we get a fever, we don't want that fever to go indefinitely because it can actually kill us. And part of that is because it's destroying our own tissues. Our immune system, our innate immune system, is not smart enough to attack, to form an attack to an invader without causing collateral damage. That's really important to understand. So what happens is, right, you get sick for 1 or 2 days, you feel really achy, and then maybe 3, 4, 5, 6 days later, your adaptive immune system starts kicking in. And this is the acquired immune response. This is the more sophisticated, wiser part of your immune system that creates antibodies. Okay. And so this is the concept of vaccines, right? We're getting exposed to some kind of foreign particle that's dead, that's not living, expose it to the adaptive immune system. The adaptive immune system creates what we call an antibody. It creates a memory trace, and it acts as a sniper that selectively targets that antigen. It no longer starts spreading bullets like crazy. So we have innate immune system, adaptive immune system, and they have a sequence of how to deal with infections and foreign invaders. So that's the normal process of a healthy immune response. In the 20 to 24, 25% of this population, the instruction manual for that process is incomplete. And what happens is the immune system encounters some of these toxins. The innate immune system sees it and it's like, hey, there's a toxin here. It induces an inflammatory response. What should happen is that the adaptive immune system should recognize that and take over and create a memory trace, but that doesn't happen. The adaptive immune system does not see it. It's invisible to these toxins. So what's the end result of that? You have this innate immune system consistently firing because the adaptive immune system is not doing its part. And that's the origin of the inflammatory response. So imagine now a patient who has all the ingredients of a cold and flu sequence of symptoms, but happening in a low grade fashion. So you don't get a fever that's going to kill you, but it's going to make you feel weird. You get a congestion, you might get pain, you might get all these symptoms at a very low grade level, but imagine that happening over the span of years or decades. We're not supposed to be in a situation like that. The body is not meant to be in a situation like that. It's a very destructive but slow evolving process. And so over time, again, this can take years, this can take decades. For some people, it can take less. That inflammatory response is going to cause dysregulation and disruption in your brain. There are specific brain regions that are very, very susceptible to this inflammatory response. Imagine if you have that ongoing for a really long period of time. And that over time is going to disrupt a whole bunch of systems in your body, basically every major system in your body. So we think about endocrines or the endocrine system, the hormones. That system starts uh, uh, getting dysregulated. We start seeing dysregulation of the digestive system. So a lot of these patients out of the blue start developing a lot of gut problems, food intolerances, a lot of IBS problems with bowel movements and things like that. I mentioned the endocrine system, so anything that has to do with testosterone, cortisol, all these hormones that are really important to give you energy. There's other hormones that are involved in a bunch of other processes. The cardiovascular system, or I should say the cardiopulmonary system. So there is your body's ability to deliver oxygen, oxygenated blood to different parts of the body becomes compromised. I mentioned the pulmonary system. So there's going to be what we call pulmonary hypertension, which is just a fancy way of saying these patients' lungs become to constrict and they feel a shortness of breath. And it's like, I can't really get deep breaths no matter what I do. There's also going to be musculoskeletal issues, a lot of pain related problems. So all of these systems, the entire body is dysregulated because of this inflammatory response. And so this is why we call CIRS a multi-symptom, multi-system, multi-symptom illness. Okay. And this is why patients develop a long list of symptoms that make no sense. And when I first came across this myself, I did not understand what the hell was going on. But once you understand the physiology and the mechanisms that are taking place, it makes a lot of sense. Over time, the inflammatory response can get so intense that it can shift the body to a later stage of CIRS where we start seeing things like um, atrophy of parts of the brain, where the brain starts shrinking. And that's not a good thing, or not a good place to be in. And you certainly want to prevent or stop that from ongoing. There could be metabolic complications where these patients will eat a healthy diet with carbs and fats and proteins, but their cells are no longer generating the proper amounts of energy so that the body can function. So you're going to get a lot of people developing chronic fatigue where they feel like they're very fatigued, their bodies are extremely heavy, and even if they do very light exercise or even taking steps can trigger this kind of stuff. A lot of brain fog and extreme brain fog can happen as a result of this. So there is an early version of this illness, which is very inflammatory. I like to call it brain on fire stage. And there's a later stage of this illness that looks more like a brain on ice, which is where the brain starts shrinking. And that's the basis of this illness. And it can be triggered by exposure to biotoxins in the interior water damage spaces. So water damage spaces where there's a lot of mold and pathogenic bacteria that grow in those spaces, or in places where there's a lot of wastewater or sewers with a lot of gas smell. There's certain toxins that can trigger this abnormal immune response. And then there's things like tick-borne infections like Lyme, Babesia, Bartonella, and things like that.